Okay, hi again, you guys. Good afternoon. It's Thursday, 28th of October. This is Structural Analysis Made Fun and Easy. This is the solution. This is University of Bolton School of Engineering, BA John Civil Engineering, Semester 1 exam, 2019 to 2020. Engineering Mathematics and Structures Module number CEI 5004. So this video is now part 2 of maybe 3 or 4. This is for statically determinancy equations of equilibrium. This video covers the topics of statical determinancy equations of, this series covers statical determinancy, equations of equilibrium, method of section, plane frame, portal frame. In the previous videos we worked out what the vertical reactions are, because we got 3 equations of equilibrium, but we got 4 reactions. We can't find the horizontal reactions, but as we just found, luckily what we can do in this frame, we can take methods of sections and take methods of sections about point D, because the moment about point D must be 0. If so, the sum of all the forces on the left hand side must equal 0, and the sum of all the forces on the right hand must equal 0. So we can do this individually on the left hand side and then the right hand side, and then we could just check. Well, once we've done that, if we found it 0, then obviously it's 0 on the left hand side and the right hand side. Then if we take both sides, it should still be 0. So here's the right. Let's start with the right hand side. So we got pin at D. We're going to take the moments. The sum of the moments about point D must equal 0. So we got D, E, F, 40 kilonewton point load acting from right to left at 2.5 meters, which is half the height at 2.5 meters. And RFH is the orange one. Just to that's a horizontal reaction. I just color coded it, as you could see in the previous video. Just thought it'll make life a bit easier. And then the RFV, we found that equals to it was 8.33. So it's still an upwards reaction. So let's take moments about D. Let's crack on. Let's take moments about D. So 40 plus. This is clockwise. If we take moments about D, the lever arm is 2.5. The force is 40 kilonewtons. Therefore, the moment is minus 40 times 2.5, and then the moment generated by the force RFH is equal to 5 meters. 5 meters times RFH, because it's perpendicular to the axis line going through the point. So the moment generated is 5 meters times RFH. So when we do minus 40 times 2.5 plus 5 times RFH, that equals 0. Therefore, if we rearrange this, we get 5 RFH equals 100. Therefore, RFH equals 100 divided by 5 equals 20 kilonewtons. So that's it. Now we can do this on the right hand side. Here's the frame again. M sum D equals 0. So 50 kilonewtons times 3 meter lever arm. That's a positive because it creates an anti-clockwise moment. That is equal to RAH. Now for this one, both the reactions are going to cause a moment, because there's a lever arm for both. There's a lever arm for both the reactions. RAH is going to be times by the height, which is 5 meters, and that's going to be positive because it's anti-clockwise about D. And RAV is clockwise about D, so that's going to be negative. So that's RAV times 6 meters. RAV, so the moments about D are plus 50 times 3 plus 5 times RAH minus RAV times 6 equals 0. There it is. Oh, that should be moments about D. Minus 6 times RAV plus 5 times RAH plus 3 times 50 equals 0. Minus, we know RAV was 41.666667. The only unknown now is RAH. Oh, well, if we wanted to, we know that RAH plus RFH equals 40. That means that RFH equals 40 minus 20 equals 20. So I could have done that first and we could be checking this. We could be checking that this works, but let's do it this way. Say we don't know RAH. So minus 6 times 41.6667 plus 5 times RAH plus 3 times 50 equals 0. So therefore, minus 3 times 50, that's 150. 3 times 3 times sorry, 3 times 50, isn't it? Because it's anti-clockwise is positive. So 3 times 50 plus 3 times 50 plus is 100 plus 150. 5 times RAH, because it's also anti-clockwise. 6 times 41.6667 is equal to minus 250. So minus 250 plus 5 times RAH plus 150 equals 0. If we rearrange this, we get 5 times RAH equals 100. That means RAH equals 100 divided by 5 equals 20 kilonewtons. Yeah. So if you like these colours, if you want a copy of the notes, please email me. So we're just going to double check. It's just like what I said, basically. Let's just check that by putting this back into equation. It was a bit further up. Equation 2. Therefore, therefore RAH plus RFH equals 40. RAH equals 20. RFH equals 20. Therefore, the equation 2 is correct. So that's it. We've nailed it. This is part 1 nailed. That's 5 marks in the bank. RAH equals 20. RAV equals, 41.6667. RFH equals 20. RFV equals 8.33333. So now, so although the question said do, I think it was the axial force next, wasn't it? I like to do the bending moment diagram. I always find those the most fun. And also while I've got the reactions, and I've been taking moments anyway, so I might as well keep on in moments mode and get the bending moment diagram done. When you're doing real life design, I think I always look at bending moment first anyway, because if I was checking the beam, I want to look at bending moment. So I always like to do bending moment first. I don't think there's any reason why you can't do the bending moment first. In the exam, you could just say, I prefer to do the bending moment first. And then you should get the same amount of marks. So let's find the bending moment using the reactions. Now we've got all the reactions, we can easily find, we're confident. I know they're right, we've checked them. The exam technique gives us 6 marks to find the bending moment diagram. That is 6 times 1.8 equals to 10.8 minutes to find the bending moment diagram. And we also know for sure now that there are 3 positions where the moments is 0. They are at the supports and the pin joint at D. So we're going to have a moment at A 0, moment at D 0, moment at F is 0. So let's start with member DF. Let's start with member DF, including point E. So there's at D there's going to be a horizontal and a vertical force. We don't need them. We don't need them just yet, because if we take moments about D, we're finding the bending moment diagram, and let's start at the other end. Sorry, let's start with F. If we move from F to E, then let's take moments below point E. Then RFV is, there's going to be 0 lever arm, so there's no moment from that force. RFH is 20 from left to right, 20 times 2, and the lever arm is 2.5, so that means there's going to be a bending moment of 20 times 2.5 at position E. 20 times 2.5 times 20 is 40 plus 10 equals 50 kilonewtons. So I think that there's going to be a bending moment at position E of 50 kilonewtons meters. That should be. It's always worth. I think like another good exam technique is like when you're doing this, if you allow yourself maybe a couple of minutes at the end just to check and you give yourself a chance to check what you've done, to check the units and stuff like that. That's always useful. So that was if we were looking at just the moments below point E. So let's double check that we've got it. So that means at D there must be a horizontal force to restore it back to the moment. That must go. That must balance to 50 kilonewtons at position E. So that means there must be a 20 kilonewton actual force in member CD to balance the moment back, because we know that at point D the moment is 0. So there's that force at that horizontal force at D is equals to 20, and it's drawn in the right direction. So the moment at B, 20 times 2.5, 50 is okay. Double check, and we can double check this goes to 0 at C. Yeah, we've already worked that out, haven't we? That was just like taking moments about point D. 40 times 2.5 minus 20 times 5 equals 80 plus 20 minus 100 is 100 minus 100 equals 0. So it's all looking fairly good and straightforward so far. At E, the moment is 50 kilonewton meters. Okay, so that's member DEF done. So now let's look at, okay then. So it looks like this bit still needs to be corrected. Sorry about that. So let's call this the end of part 2 of this series. So we found the moments in member DEF. So this is going to be at least 4 parts. But hopefully you found that useful. I must admit, okay, I've learned a lot doing these questions. So hopefully other people are finding it useful and they're learning stuff as well. Please like and subscribe to the channel if you can, and please donate if you can to let me do more videos like this. I'm just going to do more exam questions, or if someone has maybe a good question they need solving, then please email me and I can try and solve it, do a video on it if I think it will be useful for a lot of people to see. But that's basically the end of part 2. Thanks for watching. See you. Oh yeah, don't forget to tune in for part 3, where I'm going to finish off the moments, then we finish off the actual forces and the shear forces. Thanks for watching.